We need to show that A, B, and C are collinear, provided AO vector plus OB vector equals BO vector plus OC vector. Okay, let us begin. So here we'll start with the given condition. It's given to us that AO vector plus OB vector, that's equals to BO vector plus OC vector. Fine. Now that means we have 3 points A, B, and C. We also have another point O, which is going to be the origin of some coordinate system. Now we're going to join point O and A, O and B, and O and C with the help of a directed line segment. Now what we'll do, we'll change these two vectors, AO vector and BO vector, because AO vector means we have the vector going from A to O. So here we'll use the fact that since AO vector is the same as negative of OA vector and BO vector equals to negative of OB vector, which means that now we have OA negative OA vector plus OB vector equals to negative OB vector plus OC vector. Let's rearrange it. So we have OB vector minus OA vector equals to OC vector minus OB vector. Now OB vector minus OA vector, what we have done here is we're considering OB as the final point, the position vector of the final point, and OA as the position vector of the initial point. So this is nothing but the vector AB going from point A to point B. And what is OC minus OB? So that will be simply the vector BC. That means we have a vector going from B to C. Now AB equals to BC. This has the form AB equals to lambda times BC vector, where lambda is some scalar. Lambda is some scalar with value equals to 1. That means we have the points A, B, and C are collinear. So this is a criterion for 3 points to be collinear. So we have successfully showed that A, B, and C are collinear points, provided AO vector plus OB vector equals BO vector plus OC vector.